Hey, you're listening to the Debugging Dan podcast. I'm Dan. I'm taking you along on my morning walk. Today, I'm thinking about peer-to-peer. Why am I thinking about peer-to-peer? Not because I'm downloading files legally or illegally. No, I have an idea running through my head, connecting agents, AI agents, via peer-to-peer network to skip the hassle of setting up connectivity, things like that. That's why I have peer-to-peer running through my head. And I've been learning more about how they work because I'm of a generation that got acquainted with peer-to-peer via Napster. And after that, Kazaa, BitTorrent. Those are all iterations of peer-to-peer networks. And a few years ago, I learned about IPFS, which is a peer-to-peer file system. And what I remember from kind of learning about that is that there are libraries and they have set up an entire ecosystem for people wanting to integrate with IPFS or setting up their own peer-to-peer networks. And most of the knowledge that I've gained is via lib P2P, reading their docs, seeing how it works. And also I did some reading, or to be honest, I had AI summarize the Academia paper for me, which is a paper from 2002 explaining or introducing the Academia protocol. And I'm going to try to summarize what I've learned. I will probably make some mistakes here and there, but I'm enthusiastic about the topic. So I figured I'd share. So peer-to-peer is about processes or things like processes connect to each other without a central system. So how it normally works on the regular web is you use a web browser or something like that. You have a DNS address. You do a query to the DNS that returns you a IP address. And that IP address points to someone's server. And that server then responds. And the server is always online. It's always available, or it should be online, else you can't get the information. And it's always fixed. And the beauty of peer-to-peer is that it's a collection of different nodes working together, exchanging information, exchanging peers, and exchanging information on what is available on the network, routing search queries. And what I always found magical is that those peers are able to find each other. So you start up your IPFS client or your BitTorrent client, and then it knows how to find BitTorrent client or other peers without you having to point it to a DNS or something like that. And I always thought that was magic, but reading into more details, the magic kind of disappeared. So as it turns out, it's not really that magic, because there are either some nodes that are always up with the same address that are pre-configured into the application. So it always will try to first connect to those nodes, and those nodes will then help it find other nodes on the network. So it bootstraps with those nodes. So you'll always need some kind of predefined predefined address, I guess, to find or to kickstart or bootstrap. And there is a way that you can prevent that, but that the only way basically is to brute force and start scanning IP addresses and ports, hoping that you'll find a peer that can help you find other peers on help. So it's still very powerful, but it is always necessary to have a way to bootstrap things. But let me first take a step back. So you have peers that have a unique identifier, and when a node starts on the network, there are different nodes. No, there are different ways that it can be started for. I've mostly read about IPFS. So some things are P2P general and some things are specific to the libp2p implementation. But what a node first does, what it can do is do a local broadcast. So if your node is on the local network, it can do a broadcast. mDNS, kind of like Bonjour from Apple works, how they find other devices on the network. And if there it finds nodes that are already online, it will connect to those, and they can tell it, hey, you can find these peers or these nodes online. You can have some of my addresses or some of the neighbors I know. So that is a way that it first starts, but it always requires that there's some availability on the local network. And it could be that that's it. So with libp2p, you can configure an IPFS does that. You can put nodes into a local network only mode, where it will only connect to local network addresses, or it can connect to, I'll try to go to the next step. So what it will try, if it doesn't find any nodes on the local network, it will try to reach out to one of its bootstrapped nodes that it has in its configuration, or in its code, might be even try to connect up to those. And the requirement there is that those nodes are publicly available and can respond. And it could always be that your node, which is sitting, for example, on your local computer behind your router or a company firewall, things like that, it could be that your specific node isn't public. So it's difficult for other nodes to connect to you because they cannot forward the request through the router because the router blocks them. The router knows, because it does a NAT network, at least called network address table, knowing, hey, I have these outgoing requests from inside the network connecting to these IPs and these ports. So I'm expecting a request back or a response back, and I know how to forward that internally into the network. But if some node from outside the network tries to contact your node from within the network, because one of its peers or its neighbors has told where you can find that node, the router will discard the request because it doesn't know where to route it to. And then you get into another, at least I think it is, kind of magic where they do hole punching, is what they call. So in order to be able to connect those two nodes, you need a relay node. And there are two possibilities there. The relay node could just act as an in-between between the two nodes. So node A sends the data or the request to the relay node, and node B is also connected to the relay node, and the relay node just forwards the information between the two. The relay node should then be publicly available, but that's not really desirable because then the relay node is tasked with forwarding all the traffic between the two nodes, and it's also able to see the traffic. It might not be able to read it because it's encrypted, but it can see the traffic and it knows where the connection comes from and where it goes to. So that's where hole punching comes into play. And there is a relay node involved there, but only for the setting up of the connection. So node A and node B want to connect, and via the relay server, they connect to each other and they agree on specific time in milliseconds, and a specific port, things like that. So what node A does from inside its network, it sends a request to via the router saying, hey, I want to connect to this IP address using this port. And node B does the same. So when node B then a few milliseconds later, its request arrives at node A, and it knows to connect to which port, and it knows from which IP address it came. The routers from node A will then allow the request because it knows, hey, I just got a request from within my network for that specific port and IP address. So I know where to route it to. I can allow it to come in because I've seen it. And the same goes for the other way around. And that's how these nodes can directly connect to each other. They can set up the connection. The routers will allow the connection because they followed the protocol. It knows how to route the information. And that's how from behind your inner network or inside local network with, while not having a public IP address, you can connect to other non-public nodes, and you only need the relay node to set up the initial connection. After that, it will be a direct connection between the two nodes and the relay server. It does no longer have to spend resources or things to keep those nodes connected. So that means that it's important for the network to have relay nodes that can act as the in-between for setting up the other connections. So that's an important attribute. So there should be also people operating nodes within the network that say, hey, my node can be, I think at the Gaza, they called it super nodes, that translate the information and that make themselves as relay node available. So that when you bootstrap, you find other peers in the network. You can also ask peers, hey, or you connect to the relay node and say, hey, I want to connect to more peers. Can you help me connect to those? And it will help the node. So that part was more about the network setting up the connection. And when the nodes finally are able to talk to each other, then the Demlia protocol comes into play. Because when you're searching for information, it's hard when there are millions or even thousands of nodes connected to each other. It's hard to find information or to route queries through the network saying, hey, I'm looking for a file with this address, or I'm looking for information, or I want to execute this task with this specific hash. Can you help me find someone to execute it? And it's hard to just broadcast that to everything, have that go through the entire network and then come back. So what the Demlia does is every node has a hash, and every thing you want to find throughout the network is hashed. And I do want to say that the protocol is kind of complex to grasp, so I might be making some errors here, but when the node finds peers, it groups them into buckets based on distance. So it knows how to calculate the distance between two different hashes or identifiers of nodes. And so it knows which people are close and which nodes are further away. And it groups those into buckets. Like standard, every node keeps like, I believe there are 20 buckets with peers that it knows and it knows the distance to, and it then orders the buckets on distance. And it can do the same thing with a hash of something that it searches. So that could be a file identifier, it could be something else. And because of the Kademlia distance calculation and how the hashing is set up, it knows where to start querying. So based on the hash, it knows the distance, the approximate distance. It then looks into which, I believe it's called DHT, distributed hash table, for peers that are on a similar distance of that file or hash key, something like that. And then it starts querying there, and they tell it, hey, I don't have that file, but I have a neighbor which is closer to that file than I am. I'll send you the information on that node, and then you can connect to that node, and that node can then either do have the file or the information, or it already knows a neighbor or a peer that is even closer to what you're looking for. That's how it forwards the request throughout the network. And by doing that, a node doesn't need to forward your request to all its neighbors, but it can specifically pinpoint to which neighbor it's going to send the request, and that node will then be able to respond to you. And that's at least, the paper is from 2002, and I believe that's a big thing because it solves one of the problems in having to find information without having to contact all your peers. So that's a big protocol enhancement for peer-to-peer networks. That's kind of what I learned about doing it, and I think the beauty is that the system has evolved to something like a library like P2P that allows you to, I won't say easily, but that allows you to set up your own peer-to-peer network, or allows you to programmatically join an existing network, which I find interesting because for me it's always been pretty mythical what happens there with IPFS and BitTorrent, but it turns out that there are a lot of people that are very passionate about peer-to-peer networking, and I find that cool to find technological challenges that people have a lot of passion about, and make it available, and also make it available to people that are less passionate about it and just are looking for a tool. So that was my interpretation, at least, of an introduction to peer-to-peer networks. Let me know what you think. Did I make any mistakes? Did I miss essential information that I need to share in a future episode? Let me know if you liked it. Like, subscribe. The podcast is on YouTube. You can visit my homepage, debuggingdan.com. Visit my Blue Sky, leave a message, and have a nice day. Bye.